Through the narrow viewing lens of a periscope, the Pacific War was about to reveal one of its most devastating secrets to Imperial Japan. The officer gripping the handles of that optical instrument was Lieutenant Commander Takeshi Matsumura, and what he witnessed through the magnified circle of vision would fundamentally alter Japanese strategic calculations about American naval power. His vessel, submarine Thrum 36, had penetrated the American defensive perimeter, and now he found himself observing something that contradicted every assumption upon which his nation had built its war strategy. The anchorage spread before him was not simply a collection of warships at rest. What Matsumura observed defied the conventional understanding of naval logistics that had governed maritime warfare for centuries. In the protected waters of the lagoon, massive steel structures floated with an industrial presence that seemed impossible so far from the American mainland. These were not cargo vessels or transport ships, but something entirely different, something the Japanese naval staff had never anticipated encountering in a forward combat zone. 6 enormous floating structures dominated the scene, each one dwarfing any comparable facility that existed in the Japanese home islands. Through the periscope's magnification, Matsumura could distinguish individual workers moving across the surfaces of these mechanical leviathans. One of the structures held the battleship USS Alabama in an embrace that lifted the massive warship completely clear of the water's surface. The entire hull was exposed to the open air, suspended as if by some industrial magic, while teams of workers and machinery swarmed across every accessible surface. Another of these floating platforms cradled not one but 2 cruisers simultaneously, both vessels raised high above the Pacific swells. The realization struck Matsumura with the force of a physical blow. The Americans had accomplished something that seemed to violate the basic geography of warfare. They had transported their shipyards across thousands of miles of ocean and established them in the war zone itself. This was not merely a supply depot or a forward fueling station. This was industrial capacity on a scale that transformed every calculation about repair time, ship availability, and the fundamental mathematics of attrition warfare. In his breast pocket, Matsumura carried a notebook that would soon contain sketches and observations destined to create shockwaves through the Japanese high command. That night, as his submarine maintained radio silence and prepared to transmit its reconnaissance findings, Matsumura composed a coded report that would haunt Japanese naval planning for the remainder of the war. The words he chose carried implications that extended far beyond the immediate tactical situation. He wrote that the Americans possessed the capability to repair their vessels at a pace that exceeded the rate at which Japanese kamikaze pilots could inflict damage upon them. This was not warfare as traditionally understood, Matsumura concluded. This was a mathematical equation that Japan could not possibly solve in its favor. The structures that had so transfixed the Japanese submarine commander belonged to a category of naval engineering known as auxiliary floating dry docks, specifically the AFDB series. Each of these massive installations had been manufactured in sections at different American shipyards scattered across the continental United States, then towed across the vast expanse of the Pacific Ocean to be assembled like enormous steel puzzles at their operational destinations. The scale of these facilities challenged comprehension. AFDB-2 alone measured 927 feet in length, possessing the capacity to lift a staggering 90,000 tons of displacement. When operating at full capability with its complement of 600 personnel, this single floating dry dock functioned as a complete naval shipyard in its own right. The internal capabilities of these floating facilities matched or exceeded many permanent shore installations. Machine shops equipped with precision tools could fabricate replacement components for virtually any shipboard system. Foundries generated new metal parts from raw materials. Electrical repair facilities could rewire entire sections of damaged vessels. Storage tanks held 65,000 gallons of fuel oil for immediate use. The dock generated its own electrical power through onboard systems, distilled fresh water from seawater for both industrial and human consumption, and operated with an efficiency that would have been impressive even for a major established naval shipyard with decades of operational history. What Lieutenant Commander Matsumura could not possibly observe from his periscope position represented an even more comprehensive transformation of naval warfare logistics. Scattered across the vast expanse of the Pacific Theatre, 7 major advanced base sectional docks and 31 smaller auxiliary floating docks had turned every captured atoll and secured anchorage into a potential equivalent of Pearl Harbor. The strategic implications were staggering. Distance and geography, which had traditionally determined the boundaries of sustainable naval operations, had been effectively neutralized as limiting factors in the conduct of warfare. The Japanese miscalculation had its origins in planning sessions that preceded the attack on Pearl Harbor by mere weeks. In November 1941, the conference room of the Japanese Naval General Staff in Tokyo had hosted presentations of the final war plans. Vice Admiral Osami Nagano had laid out calculations that appeared flawless when examined through the lens of traditional naval logistics. American naval infrastructure on the Pacific coast consisted of 8 major shipyards, each one a fixed installation representing decades of construction and development. Mare Island in California possessed the capacity to handle 4 capital ships simultaneously while conducting major repairs. Puget Sound Naval Shipyard in Washington state could manage 3 vessels at once. Pearl Harbor, situated as the closest American facility to the expected combat zones, might handle 6 major repair operations in parallel under optimal conditions. The mathematical projections seemed to favor Japanese strategy. If the combined fleet could successfully damage or sink 20 American capital ships within the first 6 months of hostilities, the repair and replacement timeline would extend to at least 18 months, according to these calculations. Every damaged vessel would face a journey of approximately 3,000 miles back to the Pacific coast of the continental United States. The transit time alone would consume 2 weeks in each direction, effectively removing ships from combat readiness for periods measured in months. The bottleneck of limited dry dock space would create a backlog of damaged vessels waiting for repairs, further depleting available American naval strength. Admiral Isoroku Yamamoto, despite his deep reservations about initiating war with the United States, had authorized these strategic estimates. His operations officer, Commander Kameto Kuroshima, had presented detailed charts analyzing American industrial capacity in various sectors. The data showed that the United States had produced 1.5 million tons of merchant shipping during 1941, while Japan's production had reached 400,000 tons for the same period. However, Kuroshima argued that naval construction represented a fundamentally different challenge than merchant vessel production. Warships demanded specialized facilities designed specifically for their construction and repair. They required workers trained in unique skills. They consumed specific materials that could not be easily substituted. The limiting factor, Kuroshima insisted, would be the physical availability of dry dock space and the specialized repair facilities necessary for major naval vessels, not the raw industrial power that America undeniably possessed. Neither Kuroshima nor any other member of the Japanese naval staff had imagined the possibility that Americans would respond by constructing entirely new shipyards and then transporting them across the ocean to position them at the point of conflict. The conceptual leap required to envision such an approach fell outside the framework of traditional naval thinking that guided Japanese planning. The historical origins of American floating dry dock technology stretched back to peacetime commercial necessities rather than military innovation. In 1927, the United States Navy had commissioned its first self-propelled floating dry dock, designated YFD-2. This facility operated on principles fundamentally different from the fixed dry docks that had served navies for centuries. Traditional dry docks were carved from granite and reinforced with concrete permanent installations that represented enormous investments of time and resources. Floating dry docks functioned through ballast manipulation, a relatively simple principle executed on a massive scale. Pumping water from internal tanks caused the structure to rise in the water. Flooding those same tanks allowed the dock to sink lower. A vessel requiring maintenance could position itself over a submerged floating dry dock, which would then lift the ship completely clear of the water by displacing the ballast water. By 1940, with war clouds gathering across both oceans, naval planners in the United States began to recognize that this technology could be scaled dramatically and made mobile, thereby eliminating geographical constraints as a limiting factor in naval warfare. The Bureau of Ships initiated a program that seemed impossible even to experienced American engineers accustomed to ambitious projects. The specifications called for floating dry docks large enough to accommodate battleships, the largest vessels in any fleet. These facilities needed to be constructed in sections small enough to be transported across oceans. They had to be designed for independent operation in remote locations far from established infrastructure. The Advanced Base Sectional Dock Program represented American industrial organization operating at an unprecedented level of ambition and coordination. Different components of a single floating dry dock would be manufactured at separate facilities scattered across the country. Section A might be built at Everett Pacific Shipbuilding in Washington State. Sections B and C could be under construction at Chicago Bridge and Iron Company facilities in California. Sections D through G might be taking shape at Mare Island Naval Shipyard. Each individual section weighed 3,850 tons and measured 93 feet in length, 165 feet in width, and 75 feet in depth. 10 such sections joined together would create a floating dry dock capable of lifting an Iowa-class battleship, among the largest warships ever constructed. The engineering challenges appeared insurmountable when examined in detail. Each section needed structural integrity sufficient to survive Pacific storms during the lengthy towing journey from American waters to forward operational areas. Yet the sections also required precision manufacturing with tolerances measured in millimeters so they could be welded together with their neighboring sections to create a unified structure. The ballast systems incorporated into each section had to function in perfect synchronization with the systems in adjacent sections, or the entire dock might list dangerously or even capsize. Beyond the basic lifting function, these docks required fully equipped machine shops capable of manufacturing any replacement component that might be needed, from enormous propeller shafts to precision gun barrels. Commander Tamachi Hara, who commanded the destroyer Shigure, experienced American repair capabilities firsthand during naval engagements near Tulagi in March 1943. In his memoirs written after the war's conclusion, he recalled a specific incident that crystallized Japanese bewilderment at American logistics. His destroyer had successfully launched a torpedo attack that struck the cruiser USS Helena, inflicting what appeared to be serious damage. Japanese intelligence analysts, working from standard assumptions about repair timelines, calculated that the Helena would require a minimum of 6 months in a stationary dry dock to repair the torpedo damage and return to operational status. 3 weeks after the attack, Helena appeared in reconnaissance photographs taken over Tulagi, fully operational and actively engaging Japanese aircraft with her anti-aircraft batteries. Hara and his fellow officers could not comprehend what they were observing. Where was the dry dock that had performed these repairs? Their reconnaissance had identified only empty ocean and small islands in the area. The cruiser Helena had been repaired by ABSD-1, which had been assembled at Espiritu Santo just weeks before the Helena arrived seeking repairs. The floating dock had lifted the 10,000-ton cruiser completely out of the water, exposing the 20-foot gash torn in her hull by the Japanese torpedo. Repair crews had worked around the clock to seal the breach, replace damaged internal systems, and return the vessel to combat capability. The entire process consumed 19 days. The identical repair performed at Yokosuka Naval Arsenal, Japan's premier naval facility, would have required a minimum of 4 months under optimal conditions. Captain Hara's confusion reflected a fundamental conceptual gap that plagued Japanese naval planning throughout the Pacific War. Japanese military thinking conceived of naval bases as fixed installations with permanent facilities that required decades to construct and develop. Yokosuka Naval Arsenal, the crown jewel of Japanese naval infrastructure, had been under continuous construction and expansion since its founding in 1866. The Americans had created equivalent capability in 6 months of intensive industrial effort and then transported that capability across the Pacific Ocean to position it at the front lines of the conflict. Admiral Chester Nimitz, commanding American naval forces in the Pacific, understood that floating dry docks fundamentally transformed the mathematical equations that governed attrition warfare. In a memorandum addressed to Admiral Ernest King and dated January 15, 1943, Nimitz articulated this strategic insight with characteristic clarity. The availability of floating dry docks in forward operational areas fundamentally altered the correlation of forces in ways that transcended simple ship counts. A damaged vessel that could be repaired in 3 weeks at Ulithi Atoll versus the same ship requiring 3 months for repair at San Francisco represented a 4-fold multiplication of available force strength. The damaged vessel returned to combat capability faster, and it avoided the lengthy transit times that would remove it from the theatre of operations during the round-trip journey to continental facilities. Japanese naval intelligence gradually discovered this new reality through painful operational experience. The Battle of Santa Cruz in October 1942 had inflicted severe damage on the aircraft carrier USS Enterprise, one of the most valuable assets in the American fleet. Japanese intelligence officers, working from traditional repair timeline calculations, estimated that Enterprise would require 6 months of shipyard work to return to operational status. The carrier reappeared in combat operations after just 30 days, having been repaired at New Caledonia by the destroyer tender USS Vestal, working in conjunction with advanced base facilities that had been rapidly established in the area. Rear Admiral Matome Ugaki recorded his reaction to such incidents in his personal diary. The enemy's repair capabilities, he wrote, exceeded Japanese intelligence estimates by factors that defied rational explanation. Ships that Japanese forces had confirmed as severely damaged returned to battle conditions before Japanese vessels with comparatively light damage completed their own repairs. By early 1943, the United States Navy had established and was operating a comprehensive network of floating repair facilities that transformed the entire Pacific theater into an American maintenance highway. Advanced base sectional docks had been deployed and made operational at Espiritu Santo, Ulithi, Leyte Gulf, and Manus. Smaller floating dry docks serviced destroyers and submarines at dozens of additional locations scattered across the Pacific. The construction statistics revealed the hopeless nature of Japan's strategic position. Mare Island Naval Shipyard alone produced multiple ABSD sections, while simultaneously building new destroyers and cruisers from their keels up. The facility employed 46,000 workers operating in 3 shifts that maintained production 24 hours per day without interruption. In an 18-month period, Mare Island's output of floating dry dock capacity exceeded the total permanent dry dock infrastructure that existed across all of Japan. Lieutenant Commander Haruki Iki, serving as a naval architect at Yokosuka Arsenal, conducted a detailed analysis of American repair capabilities in early 1944. His report calculated that American floating dry docks positioned across the Pacific could simultaneously accommodate repairs on 18 capital ships, 36 cruisers, and over 100 destroyers. Japan's entire domestic repair capacity could handle 6 capital ships, 12 cruisers, and 40 destroyers in parallel. Beyond these raw numbers, Iki identified what he termed the multiplication effect of forward repair capabilities. A vessel damaged during operations at Leyte Gulf and subsequently repaired at nearby Ulithi returned to combat readiness in approximately 1/4 of the time required for a ship that had to steam all the way to Japan for repairs. His conclusion carried stark implications for Japanese strategy. The enemy, Iki wrote, brings his homeland to the battlefield. Japanese forces cannot sink American ships at a rate that exceeds the pace at which those ships are repaired and returned to service. The floating dry docks achieved their first spectacular demonstration of capability during the American invasion of Kwajalein in February 1944. The battleship USS Maryland absorbed multiple kamikaze hits that tore a 40-foot hole in her deck armor. Traditional naval doctrine would have dictated that Maryland withdraw to Pearl Harbor for repairs, removing the battleship from combat operations for several months. Instead, Maryland sailed 240 miles to Majuro Atoll, where AFDB-2 awaited under the command of Commander Joseph J. Rochefort, not to be confused with the intelligence officer of the same name who had achieved fame for breaking Japanese naval codes. The massive floating dock submerged its working deck, allowing Maryland to position herself carefully over the keel blocks that would support her weight. Over the course of 4 hours, powerful pumps expelled 8 million gallons of water from the dock's ballast tanks, causing the entire structure to rise and lift the 45,000-ton battleship completely clear of the ocean surface. Captain Yoshitake Miwa, commanding submarine the FY-184, observed this operation and transmitted a report to Tokyo that reflected the mixture of admiration and despair that characterized Japanese reactions to American logistics. Maryland was entering the floating dock at Majuro, he reported, with extensive visible damage that Japanese analysts estimated would require a minimum of 3 months to repair properly. 3 weeks later, Maryland departed Majuro under her own power, with observers noting that the battleship appeared to have achieved full combat capability. Captain Miwa's report concluded with the observation that captured the strategic implications. The Americans, he wrote, had made time and distance irrelevant as factors in naval warfare. Commander Mochitsura Hashimoto, who commanded submarine Y-58 and would later achieve notoriety for sinking the cruiser USS Indianapolis, wrote extensively after the war about the psychological impact of American repair capabilities on Japanese submarine commanders. His forces would successfully attack an American carrier or battleship, conduct the complex calculations necessary to estimate repair requirements, and project that the damaged vessel would be absent from combat operations for months. Yet within weeks, sometimes even days, Japanese forces would encounter that same ship again, fully operational and engaging in combat as if the damage had never occurred. Hashimoto compared the experience to fighting mythical creatures from ancient legends that possessed the ability to heal their wounds instantly and completely. AFDB-7, operating at Leyte Gulf, demonstrated the complete overhaul capability of these floating facilities when it received the aircraft carrier USS Franklin after that vessel had suffered devastating kamikaze damage in March 1945. Franklin had endured the most severe damage inflicted on any American aircraft carrier that subsequently survived the war. The attack had killed 807 sailors, a casualty toll that exceeded most ship sinkings. Standard naval procedure would have classified Franklin as a constructive total loss, too damaged to justify repair efforts. However, AFDB-7's crew of 1,000 personnel included specialists in every aspect of naval construction and ship systems. They operated continuous shift schedules that maintained repair operations 24 hours per day without interruption. Master Chief Petty Officer William Delaney later provided testimony about the Franklin repairs that illuminated the capabilities of these floating facilities. The repair crews essentially rebuilt that ship from the inside out, Delaney explained. In a stationary yard equipped with full shore facilities and unlimited resources, the work represented a minimum 6-month undertaking. The floating dock crew completed the repairs in 11 weeks while operating in an active combat zone subject to air attacks. Lieutenant Commander Sadao Kusaka flew reconnaissance missions over American forward bases as part of his duties, gathering intelligence on enemy dispositions and capabilities. His April 1944 report revealed the profound strategic shock that American logistics were inflicting on Japanese planning. Kusaka had observed Ulithi anchorage in exceptional detail during an extended reconnaissance flight. He counted 6 large floating structures that previous intelligence reports had tentatively identified as possible cargo vessels or transport ships. Upon closer examination through high-powered optical equipment, Kusaka realized these structures were mobile dry docks of unprecedented scale. One of them contained the battleship Iowa, with her massive hull completely exposed for repair work. American maintenance capacity, Kusaka concluded in his report, was not fixed to geographical locations, but had been made mobile and could be deployed wherever American forces chose to position it. The Americans literally brought their bases with them as they advanced across the Pacific. Admiral Soemu Toyoda, who had assumed command of the combined fleet after Admiral Yamamoto's death, received these reconnaissance reports with a growing sense of strategic desperation. At a staff meeting convened in May 1944, Toyoda presented his officers with the mathematical reality of defeat. If American forces could repair their vessels 3 times faster than Japanese forces could repair comparable damage, then Japan needed to sink 9 American ships for every one that Japanese forces lost in order to maintain equilibrium. This rate of exchange, Toyoda stated flatly, was impossible to sustain. Japan was being defeated not by American tactical excellence or superior seamanship, but by floating steel and industrial organization operating on a scale that Japan could not match or counter. The internal design of each dock section reflected careful attention to long-term operational sustainability. Living quarters for the crew included proper bunks rather than hammocks, galley facilities capable of preparing hot meals for hundreds of personnel, and medical facilities equipped to handle both routine healthcare and emergency procedures. Seaman First Class Robert Leckie, assigned to AFDB-3 at Manus, later described daily life aboard these floating industrial installations in terms that captured their unique nature. "Here we were," Leckie recalled, "positioned thousands of miles from our homes and families, living on this massive structure of steel floating in a tropical anchorage. The crew organized movie screenings projected onto the dock walls for evening entertainment. When no ship occupied the dock, the flat floor surface served as a baseball diamond for recreational games." "We weren't simply repairing ships," Leckie reflected. "We were a floating piece of America itself, transported across the ocean to pursue the war." The quality of food served aboard floating dry docks became legendary among American servicemen and was frequently commented upon in letters and diaries. While combat vessels often subsisted on monotonous diets of canned spam and reconstituted powdered eggs, the dry docks maintained frozen food lockers stocked with a variety of provisions and operated full bakeries capable of producing fresh bread daily. AFDB-2 served a Thanksgiving dinner in 1944 that provided 2,000 complete turkey dinners to the crews of damaged ships currently undergoing repairs, a feast that seemed incongruous with the tropical combat environment thousands of miles from American shores. Vice Admiral Takeo Kurita experienced the strategic impact of American floating repair facilities firsthand during his command of Japanese forces at the Battle of Leyte Gulf in October 1944. Kurita's battle plans had been predicated on the assumption that damaged American ships would be forced to withdraw from the operational area to seek repairs, thereby weakening the invasion force and creating opportunities for Japanese counterattacks. Instead, vessels that sustained damage simply sailed to nearby mobile repair facilities and returned to combat within a matter of days rather than weeks or months. Kurita later wrote about the profound psychological impact of this realization. Japanese forces would successfully damage an American cruiser with torpedo or gunfire, calculate that the vessel had been eliminated from combat operations for several weeks at minimum, only to encounter that same ship 3 days later engaging Japanese forces with all weapon systems operational. "We were fighting," Kurita concluded, "not merely the American fleet as a collection of individual warships, but their entire industrial system, which they had somehow rendered portable and brought to our doorstep." The most remarkable demonstration of rapid repair capabilities had actually occurred earlier in the war with the aircraft carrier USS Yorktown following damage sustained during the Battle of Coral Sea. Yorktown arrived at Pearl Harbor on May 27, 1942, bearing damage that would normally require months of yard work. Admiral Nimitz, aware that a critical battle was imminent at Midway, gave repair crews just 72 hours to restore the carrier to operational status. Yorktown entered Dry Dock No. 1 on May 28, and an army of 1,400 workers from Pearl Harbor Naval Shipyard descended upon the vessel, labouring around the clock in continuous shifts. Yorktown sailed on May 30th with her flight deck patched and boilers restored to operational status, a repair timeline that seemed impossible by conventional standards. Japanese intelligence had remained convinced that Yorktown was still undergoing repairs at Pearl Harbor and could not possibly participate in any battle near Midway. When Japanese pilots reported attacking a third American carrier during the battle, Admiral Nagumo's staff initially dismissed the reports as errors or misidentifications. Lieutenant Joichi Tomonaga, before his death during the battle, transmitted a report that the Americans possessed 3 carriers in the battle area when Japanese calculations had concluded only 2 carriers were possible. The presence of Yorktown, repaired and returned to combat in 72 hours, fundamentally disrupted Japanese tactical planning during the war's most decisive naval engagement. By mid-1944, American floating dry docks had effectively transformed the entire Pacific Ocean into an American maintenance highway, where damaged vessels could receive repairs at regular intervals across the vast expanse of water. Ships damaged during operations at Iwo Jima could sail to Ulithi. Vessels struck near Okinawa had access to facilities at Karama Reto. The distance between any combat zone and repair facilities had been compressed to a fraction of what would have been required for vessels to return to Pearl Harbor, much less steam all the way to the Pacific coast of the United States. Between 1942 and 1945, American industrial capacity produced 7 major advanced base sectional docks, 31 auxiliary floating docks of intermediate size, and 55 smaller auxiliary repair docks designed for minor repairs and maintenance. The combined lifting capacity of this floating repair infrastructure exceeded Japan's entire permanent dry dock capacity by a factor of 4. Each ABSD cost approximately $40 million to construct and deploy, an investment equivalent to building a light cruiser, but the strategic return on that investment far exceeded the value of additional combat vessels. Rear Admiral Kizo Kimura captured the psychological impact of American industrial dominance in entries written in his personal diary. The Americans construct floating dry docks the size of city blocks, Kimura wrote, and then tow these massive structures across the Pacific Ocean as if they were already certain of ultimate victory. They are building the infrastructure of peace while we are still fighting the war itself. Chief Petty Officer Marcus Thompson, serving as a hull repair specialist aboard AFDB-2, had undergone 18 months of intensive training at Mare Island before deploying to the Pacific. His team of 40 welders possessed the skills and equipment necessary to repair torpedo damage that would have challenged many major shipyards. "We became artists specializing in destruction repair," Thompson recalled in later interviews. "A destroyer arrives with her bow completely blown off by a torpedo hit. We would fabricate an entire new forward section and weld it into place within 5 days. The scope and pace of work seemed impossible by peacetime standards, but became routine in the pressure cooker environment of wartime operations. The medical facilities incorporated into floating dry docks added another dimension of strategic value beyond their primary mission of ship repair. Each major dock included a hospital section with fully equipped operating rooms and recovery wards. Dr. Lawrence Steinberg, serving as Chief Medical Officer aboard AFDB-1, performed over 200 major surgical procedures during his deployment, treating injuries from combat operations, industrial accidents during repair work, and routine medical emergencies that arise when hundreds of men work in close quarters under stressful conditions. In November 1944, Japanese submarine the Pao 365 received orders that reflected new strategic priorities in the face of American logistical superiority. Rather than hunting for warships as targets, the submarine was directed to penetrate the American anchorage at Ulithi and specifically target the floating dry docks rather than aircraft carriers or battleships. The mission reflected Japanese recognition that destroying American repair capacity might prove more valuable than sinking individual warships that could be repaired or replaced. The submarine I-365 was destroyed by American anti-submarine forces before reaching Ulithi, becoming one of 6 Japanese submarines lost while attempting to attack floating repair facilities during the course of the war. The only successful Japanese attack on American floating dry docks occurred on April 22, 1945, when Lieutenant Saburo Shimbo and Ensign Chuhei Okubo, flying at an altitude of 14,000 feet, misidentified empty floating dry docks ABSD-2 and ABSD-4 as aircraft carriers and initiated an attack. A follow-up strike managed to inflict damage on Section G of ABSD-2, but the dock's repair crew, working on their own facility, completed repairs to the damaged section within 3 days, demonstrating the redundancy and resilience built into these systems. Commander Masataka Okumiya, analyzing the strategic implications of floating dry docks after the war, articulated Japanese frustration with an observation that bordered on the philosophical. Japanese forces could occasionally succeed in damaging individual warships through kamikaze attacks or conventional naval engagements. However, the floating dry docks seemed to multiply like living organisms. They were not simply floating platforms for ship repair, but represented floating factories that possessed, in a sense, the ability to reproduce themselves by repairing damage to their own structures and by training new crews to operate additional facilities as they arrived from the United States. The Okinawa campaign, extending from April through June 1945, witnessed the most concentrated damage infliction of the entire Pacific War. Over 400 American ships sustained damage from kamikaze attacks during this prolonged battle. A fleet of floating dry docks established at Karama Reto operated continuously throughout the campaign, in some cases lifting damaged ships for repair, even while the anchorage remained under air attack. Captain Toshiyuki Yokoi, commanding kamikaze operations, recorded the futility of Japanese efforts in reports to his superiors. Japanese pilots were sacrificing their lives to inflict damage on American vessels, Yokoi noted, only to witness those same ships returning to combat operations within a matter of days. The floating dry docks at Karama Reto could repair vessels faster than Japanese forces could organize and launch new waves of attacks. Of the 404 ships damaged during the Okinawa campaign, an astounding 387 were repaired sufficiently to continue operations without requiring withdrawal to permanent base facilities. The destroyer USS Lafay, which absorbed hits from 6 separate kamikaze aircraft on April 16 and remained afloat through what seemed miraculous circumstance, was operational again by May 1. The repair timeline of 2 weeks for a vessel that by rights should have sunk demonstrated the peak capability of American forward repair infrastructure. Captain Minoru Genda, reviewing captured American planning documents after Japan's surrender, discovered preparations that would have brought 12 major floating dry docks and 40 smaller facilities to Japanese home waters to support the planned invasion of the Japanese home islands. Genda calculated that even if Japanese forces had succeeded in damaging half of the invasion fleet on a daily basis, American repair capacity would have restored damaged vessels to operational status faster than Japanese forces could reload their weapons and organize follow-up attacks. The mathematical impossibility of defending against such an invasion became grimly apparent in hindsight. Working conditions aboard floating dry docks involved constant danger from unexploded ordnance lodged in damaged ships, toxic smoke from battle damage, and the industrial hazards inherent in heavy repair work. AFDB-3 lost 7 workers when a bulkhead collapsed during repair operations on USS Pittsburgh, crushing the men beneath tons of steel. Despite such dangers and the harsh living conditions in tropical combat zones thousands of miles from home, morale among floating dock crews remained remarkably high throughout the war. The motto, painted in letters 10 feet high on AFDB-2, read simply, "We keep them fighting," a statement of purpose that crew members took seriously as their contribution to victory. Admiral Soimu Toyoda's interrogation by American intelligence officers after Japan's surrender identified 3 decisive factors that had led to Japanese naval defeat in the Pacific. American submarine warfare had devastated Japanese merchant shipping and strangled the island nation's economy. Fast carrier task forces had swept Japanese naval aviation from the skies and dominated the surface of the ocean. But Toyoda identified a third factor that was less obvious but equally decisive. "Your floating dry docks," Toyoda told his interrogators, "killed the Japanese Navy as surely as your bombs and torpedoes accomplished. You made time and distance irrelevant as constraints on naval operations. You brought your homeland's industrial power directly to our home waters and positioned it where we could not effectively attack it." Between 1943 and 1945, American floating dry docks performed 1,847 major ship repairs and 8,234 minor repairs across the Pacific theater. They succeeded in returning 95% of damaged vessels to operational service within 30 days, a statistic that would have seemed fantastical to naval planners from any earlier era of warfare. The average repair time for serious battle damage had been compressed from months to weeks, fundamentally altering the arithmetic that governed attrition warfare. Commander Joseph Rochefort, the intelligence officer whose code-breaking work had contributed to American victory at Midway, offered a penetrating insight into the nature of American success in the Pacific when asked about critical factors in post-war interviews. The Japanese military, Rochefort observed, believed they were engaged in combat against American ships and American fighting men. What they were actually confronting was the entire American industrial system, which had been rendered portable and deployed to the point of conflict. Every floating dry dock represented Detroit's automotive assembly lines, and Pittsburgh's steel mills made manifest in structures that could float across oceans. The organizational vision that made floating dry docks possible came from officers like Rear Admiral Ben Morial, who understood that American industrial superiority meant nothing if that capacity remained confined to the continental United States. Morial and officers like him envisioned transforming industrial power from a homeland advantage into a deployed weapon system that could be positioned wherever American forces operated. This conceptual breakthrough proved as important as any tactical innovation or technological advancement in determining the outcome of the Pacific War. Mare Island Naval Shipyard employed 6,000 women by 1943, integrating female workers into positions traditionally reserved for men as part of the massive expansion of America's industrial workforce during wartime. Marjorie Muller, one of the first female welders hired at Mare Island, worked on Section F of ABSD-2 and later reflected that every perfect weld she made meant American sailors would remain safe aboard vessels that had been properly repaired. The Chicago Bridge and Iron Company employed 4,000 African-American workers at its California facility, where they participated in building 3 ABSD sections and achieved production rates that exceeded some integrated yards, though their contributions were often minimized or ignored in contemporary accounts. Admiral Arleigh Burke, who would later serve as Chief of Naval Operations, frequently cited floating dry docks as examples of American innovation solving strategic problems through industrial means. The Japanese forces, Burke noted in numerous speeches and writings, brought superior training and tactical excellence to the Pacific War in its opening phases. The United States brought floating dry docks and the industrial organizational capacity they represented. Japanese naval doctrine made the ocean a battlefield. American industrial capacity made that same ocean a factory floor where the industrial might of an entire nation could be brought to bear on the problem of sustaining naval operations indefinitely. Japanese naval attachés had filed reports on American shipbuilding capabilities throughout the 1930s as part of routine intelligence gathering. But these observers had interpreted what they saw through the lens of their own experience and assumptions. Commander Yoshiro Fujimura had visited Chicago Bridge and Iron Company facilities and observed the sectional construction techniques being developed for industrial applications. His report to Tokyo noted that Americans built industrial plants using modular construction, fabricating sections that could be transported and assembled on site like children's toys. He found this approach interesting from an engineering perspective, but dismissed it as irrelevant to naval construction, which he assumed would always require permanent facilities and traditional construction methods. As the war reached its conclusion, American industrial production of floating dry docks continued unabated. AFDB 8 through AFDB 14 were under construction when Japan surrendered, destined for the invasion of the Japanese home islands that never occurred. These facilities, representing millions of hours of labor and vast quantities of steel and equipment, would instead be deployed during the post-war period to support American naval forces during the occupation of Japan and later conflicts. The story of American floating dry docks in the Pacific War represents the collision of fundamentally different philosophical approaches to the nature and application of military power. Japan conceived of power in traditional terms that emphasized warrior skill, tactical excellence, and the spiritual qualities of fighting men. The United States conceived of power in industrial terms that emphasized production capacity, logistical sustainability, and the ability to maintain and repair military forces in the field. The Pacific War tested these competing visions of warfare under the harshest possible conditions, and the results demonstrated that industrial capacity deployed effectively could overcome traditional military virtues. Once American floating dry docks had been deployed across the breadth of the Pacific Ocean, each individual facility represented the entire American industrial system made mobile and brought to the battle zone. They embodied Detroit's assembly lines that had made America the world's leading automotive producer. They incorporated Pittsburgh's steel mills that had made America the world's largest steel producer. They drew upon decades of industrial development, labor organization, and manufacturing expertise that had transformed the United States into an industrial colossus. Against such overwhelming industrial might deployed with strategic vision and tactical flexibility, no amount of traditional military excellence could ultimately prevail. Admiral Soemu Toyoda's final assessment of Japanese defeat, delivered during his interrogation by American intelligence officers, captures the ultimate significance of floating dry docks with devastating clarity. "You defeated us," Toyoda stated, "the moment your floating dry docks arrived in forward positions across the Pacific. Japanese forces could sink your ships in battle, but you possessed the capability to raise them again and repair them where they were damaged. This meant you could absorb any level of losses and continue fighting without pause." The Pacific Ocean itself had become an American lake by the war's end, not because you controlled every square mile of its surface, but because you could maintain your control of strategic positions anywhere and at any time. "We came to realize," Toyoda concluded, "that we were not fighting merely against ships and aircraft and fighting men, but against an entire industrial system that had somehow learned to float across oceans and position itself wherever American forces chose to operate."